So if you take this edge first perspective, there are several what we call design patterns that emerge. And these design patterns will be different based on the device or devices you're working with, the specs of those, the use case, and a whole plethora of other custom requirements. So the first design pattern that we'll see is what we call native edge, which is great for static model workloads. In fact, what I just showed you was an example of that, where the compute, the processing is happening on the device itself. So we use Mozzie as our central ModelOps platform. We have our model. We remotely push that to the Raspberry Pi, and then it was operating in a way that we could access that via API. And that's all facilitated via and orchestrated, via Mozzie's edge-centric solution. So, you can deploy models anywhere, and then on the device, there's a whole plethora of tasks you can do, right? So, Mozzie Edge can start the container, it can stop the container, restart the container at any time, and then on a case-by-case basis, you can customize resource allocation, on per container basis. So, super flexible, and again, very simple demo that we suddenly can rapidly scale up to hundreds, thousands of devices if we want to.
Yeah, some great examples of that in practice today include a lot of computer vision scenarios. So any situation where you want to be able to run a model right on a GPU accelerated smart camera, it's a great example of that kind of use case. Native edge, as well as sensor data. So if you're processing sensor data live in the field, scenarios like sort of machine failure prediction, or if you're trying to sort of analyze real-time location data for supply chains. We work with a customer who's actually looking at trying to use this information to reduce forklift collisions by basically alerting drivers as they're whipping around corners inside a big factory. So scenarios where you need that data kind of rip through really fast, this native edge approach is really helpful. So computer vision and sensor data, those are two scenarios where you may consider this architecture.
Yeah, yep, that's great. Thanks, Seth. Moving on, the next design pattern we see is similar to what Seth was just describing, something that we call network local, which again is similar to native edge, but can handle larger workloads. So let's do a quick comparison here. We can deploy a single model to that Raspberry Pi, and you saw some of the telemetry data that was returned. And maybe you can get away with a 500 megabyte model that requires a couple hundred megabytes of RAM to run. What we're now proposing is deploying your model or models to an edge server, a more enterprise grade server, for example, the HP Edgeline series. It's a bigger box with dedicated resources that can handle these large data workloads. You could deploy dozens of large models, 20, 30, 40, 50 megabytes or gigabytes of RAM on a single server box, and it can process data simultaneously. So let's take, for example, a factory where there are hundreds or thousands of sensors and cameras collecting all different types of data. And in this factory, there may be a handful of AI, ML use cases where you want to process all this data at the same time. So what you can do is hook up all your models and your edge server to all those sensors. You can process all that data and run things like different use cases for employee safety, air quality index prediction or PPE detection, supply chain management and inventory predictions, quality assurance on the assembly line, to even perimeter security with computer vision. You can run all those workloads simultaneously. And then when you think about scaling this out to hundreds or thousands of factories around the globe, makes it really easy. Again, all being able to configure that from your central ModelOps platform, as we mentioned.
Yeah, the really nice part about that, especially in the manufacturing or like retail scenario, is that you have a central hub. So for the enterprise, for governance purposes, there is one view of like where all these models are, what model versions are in play, who's using them. But when it comes to operations, that model is literally located on the factory floor or in the retail store. And so you can guarantee that the model is going to keep performing even if AWS has a hiccup, network connectivity goes down. You don't have to worry about the actual execution of it, while you still get the benefits of the governance and visibility into what the heck is happening across all your different locations. So those are two markets where that approach is really helpful.
Yeah, absolutely. Great examples. Moving on, the third of 4 design patterns we'll talk about is something that we call edge cloud. This is great when you may have several sites where the model workload at each site varies significantly. And so instead of just deploying your machine learning models to that edge server, now what we're proposing is deploying your entire ModelOps platform onto that edge server. So imagine you deploy your entire platform to the factory. This opens the door to several benefits. Number one, the factory has access to your entire library of models instead of just a few. It would be quicker to test different models, to switch them in and out for different applications. You still have the flexibility to send models directly to small sensors in your factory. And data science teams, this might be very advantageous for them, who are assigned to a particular site, and maybe the data for a particular site is so different than any other site that the data they work with, and as a result, the models they build will only really be relevant for this one instance. Then by creating this kind of private edge cloud, your models, your data, and all the infrastructure and sensors located in one area kind of are confined to this private edge design pattern. Seth, any other examples to add to this one?
Yeah, I'll give another one because I have to make all of my examples today about the ocean. Big ships also have server racks on them. And so this is a great example of a scenario where you might want to deploy a whole range of machine learning models to a location that has sufficient computing resources. But again, you can't guarantee it's going to have network connectivity. So that could be an oil rig, it could be a ship, it could be a server rack in the closet of a national park building that's using machine learning models to track various weather data. So all these scenarios where you're not always certain what access you're going to have to dedicated cloud resources, this gives you kind of the benefits of the cloud, a central hub with all of your models, but locally available. So it's just another way to think about that edge-centric mindset.
Yep, that's great. Thanks, Seth. And finally, the last design pattern is something that we call remote batch, which is great for running large batch jobs in remote Spark clusters. So imagine you're a multinational corporation or a global bank and you collect millions of data points daily. And perhaps that you store all that data in clusters that are co-located by region, right? And so you may have a dozen Spark clusters around the globe. And instead of taking all that data and sending it to where your models are, instead you can take models and send it directly to those Spark clusters and run those large batch jobs. And then again, because of that central configuration platform or hub, you're able to very quickly send updated models out to those clusters and receive any telemetry or monitoring data back that you may need to make improvements.